Here we are again, hanging out at the hangar. Overcast day here in South Alabama. Thought I'd make a quick video because of some experiences I've had. I've had two, not one, but two alternator failures on cross countries. And I've made videos about those things and the alternator itself. But one thing I really haven't thought about other than in my own mind was if you're flying along and you do have an electrical failure or an alternator failure, your what you shut down and your current draws and how many amp hours you got on your battery. You know, just kind of some food for thought. I've got it on my checklist here of, in detail, some things I could shut down. I'm going to show that to you. And, you know, you can check the paperwork on this stuff and what the current draw is on each of it. But one thing I decided to do, and that's the topic of today's video, is to see what the actual current draw is with my little meter here. I would have an idea of how long my batteries would last if I chose, you know, to press on in the event of an alternator failure. So let's look at my list. And then I made another quick list that I just wrote down here of stuff that I think I'd like to be able to keep on in the event of an alternator failure. When I get in the plane, I'm going to try all of these things on, everything else off. And then there's two things on the list that I can do without, and I'll explain why in a second. But anyway, here's my list of things that I could actually do without, that I can shut down in flight. As you can see, wig-wags or landing lights, turn those off. I can stop the strobes, nav lights, fuel pump off. I can turn my autopilot off. Of course, I can turn the transponder off. I can turn my comm radio off. I can turn the dynon, the EFIS, and the EMS side off, and I can turn my iFly GPS off. And I can just fly home, which I did one time, using just my phone. Now here's my little list that I made of stuff that I'd like to have on. My EFIS, my EMS, the transponder, ADS-B. That's a huge safety thing there with traffic. My iFly GPS and the comm radio. Now these two I could turn off. I've got a handheld radio that I keep in the plane, and I have an external antenna mounted. My iFly GPS, I can turn that off and use my phone because I have the same software on my phone. All right, like I said, I'm going to use this little amp meter here, or voltmeter, to test the current, and this little converter that converts AC into DC so I don't have to use the batteries. One thing I decided to do, I'm going to turn everything on and see what my total current draw is with everything in the plane on. Just because I don't really know. I'm guessing around maybe 20 amps. I think I've got everything set up here. Got to put this up there so it blocks out the sunlight. Hopefully you'll be able to see that. Well, I think I've got everything set up here. And there's my little converter box. I'll plug it in right here. And this just, the hot wire goes 12 volts going to the alternator lead. And I got the ground hooked right down there. First, plug this in. All right, we got current going to the plane. I'm going to go turn everything on. Avionics master, nav, strobes, landing lights, dome light, fuel pump. Okay, that's everything on. Looks like I'm drawing 15 amps. All right, now I'm going to shut everything off except those items that I listed earlier. Fuel pump off, dome light off, landing lights off, nav and strobe off. Now that's just EMS and the EFS and the transponder, the comm radio, and my ADS-B. Let's see what that is. All right, I'm going to change the setting on that down to 20 amps. It's back to AC, DC. All right, about 4.6 amps. That's not too bad. The only thing that would increase it is if I was talking on the radio. Of course, when you key the mic and transmit, it goes up. Now I'm going to see what it is with the iFly GPS off and the comm radio off, because I have an alternate source of those that won't use the aircraft's electrical power, but I'm happy with that. That's less than 5 amps. So let me turn the other stuff off. All right. So 3.6 amps just by shutting down the comm radio and the iFly GPS. Well, that's really good. So really, shedding those two other items doesn't yield but what, 1.5 amps? And with a 44 amp hour battery, I could go, if I'm using 5 amps, I could go what, 8 hours? That'd be 40 amps used, but I'm not going to fly for 8 hours with a dead alternator. My bladder's not that big anyway. I wouldn't be a fan of running my batteries down. I have 2 batteries, as you can see. I've got a main and an auxiliary that I have labeled as such right there. They're both 22 amp hour batteries, so I have a total of 44 amp hour reserve without an alternator. And drawing no more current than that, it really would not be, an alternator failure should be a non-event in VFR conditions, that is. I'm here at home and getting ready to edit the video, and I thought of something else that I want to share with you. When I was doing that current draw test, and just to pick 5 amps to keep it nice and round, and I've got 2 22 amp hour batteries for a total of 44 amp hours of available current. That doesn't necessarily mean that I could run and get 5 hours out of those batteries drawing 5 amps. And the reason is because most avionics equipment requires a minimum of about 10 volts up to 30 volts to operate, because they operate in both 12 and 24 volt systems. But anyway, their minimum is about 10. So as I'm using that, you know, if I've lost an alternator and I'm flying along and I continue to use that 5 amps, I don't know what it would take, but as soon as that battery voltage hits 10, that avionics equipment's shutting off. So food for thought, that if you do have an alternator failure, it still pays to go ahead and get on the ground as soon as possible. Once again, thanks for watching. Appreciate your comments, and please like and subscribe. We'll see you next time.